All right, let's begin. Algebra 1, 5-1, our brand new unit. This whole unit is systems of equations. So we have a line, now we're adding two lines, and we're seeing what happens with two lines. Yeah, today's date is Thursday, November 19th, 2020. Giorgio, yeah.
It's the paper.
Say again, you cut out there for a sec.
I don't have the 5-1 because
Yeah, no one does. I just passed it out this morning. Yeah, I know. It'll
Oh,
be to take notes. You can just take briefer notes if you have
okay.
paper.
Yeah.
All right, our objective today. Ripley.
Test solutions to equations and solve a system of equations while graphing.
There it is. All right, so let's start off with some vocab to get us started. Whenever you see the word solution, so underlined solution. A solution just means it's a number that if you plug it in, both sides are equal to each other. So both sides are the same. For example, if I plugged in, I don't know, 3 and 3, and I got the number 5 is equal to 5, that means that that was a solution. And a system of equations, that's a number, this number or more equations. Anyone want to take a guess as the number? I just said it right before we started our lesson. How many lines are we looking at? Ripley? 2, yeah, 2 or more. You could have 2 lines, you could have 3 lines. All of those are system. And Braden, if you can work on your test and you can watch the video here later. And then a solution to a system of equations, putting both of those words together, we have a solution and we have a system of equations. That means a number that is a solution to, assuming that we have 2 equations, then Jose, to both of them. Yeah. So you can say either all or both equations. If you have 2 equations, then both. And I know I'm moving fast, especially for Giorgio that does not have the notes, and that's okay. Try to summarize the vocab as best you can. All right, so example 1. We have 2 equations. These are both lines. I know that they're lines because this is x to the power of 1, y to the power of 1. They're linear. All right, I'm asking, is 1, 2 a solution to the system? What that means is I'm going to plug in x equals 1, y is equal to 2 for this equation and this equation. If I get the same number equal to the same number, that is a solution. If it's not, then it's not a solution. And it has to work for both the first equation and the second equation. If it only works for one, but not the other, it is not a solution. It has to work for both. All right, here we go. Let's plug in x is equal to 1, y is equal to 2. Let's plug it in for the first equation. So over here, someone tell me what to write. It's going to be 2 times what? Someone that hasn't participated. We've only got 2 people that have participated. Yeah, Haiti. 2 times 1, and 1 is for x. So plus, and then what? Plus 2 is equal to 4. Perfect. And you guys can probably do the mental math. 2 times 1, 2. 2 plus 2, 4. 4 is indeed equal to 4. So you can simplify over here. You can say 4 is equal to 4. You can give yourself the giant check mark. I guess can't write over there on my tablet. 4 is 4, so this is a solution. 1, 2 is on the line. If I were to graph this line, 2x plus y is equal to 4, what would that look like? That would be something that looks, let me give a quick sketch of this line. If you have your axes right here, your y coordinate, your y-intercept is 4, your x-intercept is 2. So it looks something like that. On this line, 1, 2 is a solution. It's on this line. So you can say that point is, it lives right about there. It is on the line. All we're checking is it on the line? It has to be on this line and it has to be on that line as well. All right, now we're going to plug in for the second equation. Same thing. Someone read me. What do I have? Trying to get someone new in here. It's gonna be 3 times something. 3 times Ashley. 3 times 2, good. Is equal to, keep going, Ashley. 1 times 1. All right, let's do some mental math. 1 plus 1, yeah, sorry, I forgot the plus. Log the teacher error, it's extra credit. All right, and then what is the left-hand side and right-hand side now? Oh yeah, she actually gave me the credit card here too.
Perfect. Okay. I didn't know if she gave it to you or not, so you're good to go.
Yeah, thanks.
I just usually put it under Jeannie Sasson, Eastern Sierra USD when I buy it, so it's under her, and then I'll put it in a PO. Once you let me know how much it is,
Okay,
just send me the receipt and I'll put in a PO real quick.
sounds good. Thank you.
Awesome.
All right, left-hand side, what is it, Ripley?
It is 3.
3 times 2, which is
6.
6, and the right-hand side is, you got this?
2.
2, all right. 6 is not equal to 2. We put a giant X here. No. No. So our answer here is no. It has to work for both of the equations. It only worked for one of the equations. Let's try another one. You guys all right now, do example number 2. Plug into both of them. Is 3, 5 a solution? And it has to work for both. I'll pause the recording. All right, quiet raise hand. Who can do the first equation? Diego.
Okay, so it would be 5 times 5 minus 8 equals 6 times 3 minus 1.
And when you boil down both sides, you get?
On the right side, you would get 8, you get 17 because you want to subtract 1
Yep.
from 18.
Good.
And then on the left side, you would get 17 because you would subtract 8 from 25.
And what do you conclude from that?
17 equals 17, so it is a solution.
That is a solution to that line. Perfect. Thank you. Graphically, that point is on that line. Thank you. And then the second equation. Who can do the substitution? Alden, you want to do it for us?
Okay. So it would be 4 times 3 plus 3 equals 3 times 5.
And if you boil down the left-hand side and right-hand side, Alden, what do you get?
12 plus 3.
Which is?
15.
15 on the left. What about the right-hand side?
On the right-hand side, 15.
15. What do you conclude from that?
It's solution.
It's a solution to that equation, and therefore a solution to both equations. Yeah, thank you. All right, so the answer here is yes, because it worked for both of them. Yes, it is a solution. All right, so in this unit, you have to be a master of graphing in all forms, and that was last unit. Last unit was unit 4. You know how to graph in standard form. You know how to graph in slope-intercept form. You know how to graph in point-slope form. As a review, we'll go ahead and cover them again because you're going to be using them all in this lesson. All right, what's the general form for a slope-intercept form? What's the general equation? Does anyone remember? Giorgio said it all of like unit 2, so he knew a long time. Yeah, go for it, Giorgio. Giorgio.
Y equals MC. Wait, no. Wait, Y equals MX plus B.
There it is. Thank you. And then standard form, which might help Braden on assess, but that's okay. What is standard form? Ripley.
Is that like Y? I think I got some wrong on that test.
That's okay. Standard form. Standard form looks like Alden, yeah.
It's like X plus Y equals something.
Exactly. Yeah. X plus Y is equal to some number, and usually there are coefficients out here. You can say like AX plus BY is equal to some other number C. Yeah, exactly. So those are the two types of forms that it's going to be giving you on the homework tonight. It will not give you point slope form, although you should know how to do that one as well. So let's review, how would you graph each of these? And remember that M over here is our slope and B is the y-intercept. If I'm being very specific, I would call B the y-coordinate of the y-intercept, because technically it should be 0, comma, whatever that number is, B. All right, so step number 1, graph the y-intercept. Step number 2, use slope to find the second point. And then for you just have like 2 steps over and over again for standard form. Find and graph the x-intercept, then find and graph the y-intercept. So how do you find the x-intercept again? The x-intercept. You set a number or a variable equal to a number. Does anyone remember? Diego?
Y equals 0.
Yeah, you set y is equal to 0, and therefore to find the y-intercept, you set something else equal to something else. Ripley? X is equal to 0. There it is. All right, let's see how that works on the back side. Let's flip it over after everyone's done copying this down. Flip. Flip, flip, flip. No one needs more time? Okay. All right, so find the solution to the system of equations. I gave you a slope-intercept equation and a standard form equation. Look at example number 4. Same type of thing, slope-intercept and then standard form. Good morning, Zeke. Wait, how is he here and Giorgio's there? What's going on?
George's mom wouldn't let him come to school.
Oh, okay. I was going to say the world is backwards. All right. So graph y equals -1/3 x plus 3. I'll do example number 3 with everyone, and you guys are all in charge of doing example number 4. All right. So volunteer, help me. Y equals -1/3 x plus 3. There are 2 steps. I guess 3 if you want to be really specific. What's our first step? Ripley, go for it. Graph the y-intercept, which is 3. Again, this 3 is right there. And then I use a slope of -1/3. Again, this -1/3 is a slope. Notice that the slope doesn't have any x attached to it, just the -1/3. How am I going to use the slope of -1/3 to find another point? How many to the right, how many up will I go from my y-intercept? Sorry, Ripley, can't call on you. You've just been so much. I need to make sure other people know what they're doing. Still haven't heard from Carlos. Oh, Zeke's in here too. Zeke, I wonder if you can, on the spot, all of a sudden, tell me how to do this. All right, here we go. We graphed the y-intercept. The y-intercept is at 3. We're at first equation. So Zeke, from here, what do you do? How do I use the slope of -1/3 to find the next point?
You would go down 1 and then to the right 3.
There it is. Everyone graph this next point, down 1, right 3. And you can do that pattern over and over and over again. Again, when you have the slope, if slope is equal to -1/3, that's the same thing as -1 on the top, a +3 on the bottom, which means 1 down and 3 right. And then do that again. 1 down, 3 right. 1 down, 3 right. 1 down, 3 right. Oh, it's off the graph. And then do the reverse of that. You can do 1 up, 3 left. You can have as many points as possible to have a very clear line. And then you go ahead and just sketch a line that goes through those points. I know that we don't have rulers. Thank you, COVID. There is that first line. That is because I cheated. I have this tool that makes straight lines. But thank you. I wish I could take the pride of making straight lines. I'm terrible. All right, and next we have this standard form equation. 7x plus 6y is equal to 48. Giorgio, go for it.
Okay, I believe add 6y to the right side and then subtract 48 to the left side. So you have 7x minus 48 is equal to -6y.
You are 100% correct. You're converting it to slope-intercept form.
Can I do a quick breakfast lunch count for today? Pancakes for breakfast.
But it's different lunch, huh?
Yeah, so
Should I finish it?
Hold on. I want to talk about it
And then what? Huh?
for tomorrow.
This is for today, breakfast. Today is pancakes. You guys already ordered for tomorrow with Mr. Sandell earlier, but today is pancakes and lunch is pizza. Since we weren't here, we couldn't do that. Hang on a second. Am I in high school? This is Heather. Hello? Yes. Okay, okay, I'll put him on the list. Okay, thank you. Bye. Sorry.
Multitasking.
Trying. I'm like, oh, it's beeping. I think that means it's actually ringing. Okay, so I got Jose, Diego, Brayden, Zeke, and Carlos for lunch. Did I miss anybody? Okay, thanks, guys.
Thank you.
Just to know, if it's not too late, before we got to lunch and breakfast.
Yes.
Sorry.
I should have done that while, yeah, things were happening. Where are you, Zeke? There you are.
And also, do you have any pencils? Because I'm.
Miss Heather gave me a bunch, and then Mr. Brown put them in a weird place, I'm sure.
Mr. Brown, what'd you do with all the pencils we got? Probably like under the floor.
He like dug a hole outside and buried them.
Probably. I can move them down.
Yeah, we're looking for an extra pencil. I asked Miss Heather for a bunch of pencils, and sorry, Zeke, I have no idea where all of our extra pencils are. Yeah, does anyone else have a pencil that they could maybe loan him?
I can look.
There's this pen right here if you want to be hardcore.
This is
Mr. Brown's his nice pen. Wait. I have one. Let's make it nice and gross for you.
Oh, that's nice.
All right, a hand sanitizer pen. Mr. Brown, this is video evidence that I'm sorry I gave your pen away. All right, come back here. So Giorgio said that we're going to be rearranging this equation, which works if you decide to turn it into slope-intercept form, but there's an easier way. If you come back up here, all you need to do is find and graph the x-intercept, find and graph the y-intercept, and you're done. That's the easiest way to do it. So, Giorgio, what would your first step be if you want to do it the slightly easier way?
So if you want to find the intercept, plug in 0 for x. So it's just going to be, or like you said, you can cover your finger on it. And then, so it'd be 6y is equal to 48, which would be 8. And then to find x-intercept,
I'll let someone else
cover
do
up.
I definitely
Okay.
know that you know how to do it. Yeah, I just want to make sure that everyone can follow your y-intercept step as well. Again, what he's doing is he's holding his finger over the 7x because you're plugging in 0 for x. 0 times 7 is 0. It's not even there then. Hold your finger over the 7x and you get 6y is equal to 48. Divide both sides by 6. 48 divided by 6 is 8. So that means we can graph the y-intercept. The y-intercept, I'll do this maybe in yellow or orange, whatever the color this is at 8. So if maybe I can grab all this and make it orange as well, just a color code. And then I'm going to find the x-intercept. Someone else, show me how to find the x-intercept. Zeke.
Y would equal 0 because that's how intercept works, and then that would make 6 times 0, which is 7x equals 48. So then divide 7 by
Thank
both
you.
sides, you get x equals whatever that is.
Yeah, what happened there? Why is it a 48? Because if it was 49, it would be 7.
But then it wouldn't be equal to 6.
Yeah, that's super weird. What did I do?
Did you make a mistake?
Yeah, the problem will generally work. I don't know why I didn't do that. I'm sorry. That is super weird. Yeah, I'm sorry. Well, if everyone wants to pull out your extra credit tracker and just log one teacher mistake, everyone gets one freebie. Sorry, that's my bad. I thought I fixed that for this year, but I guess I didn't. That's my bad. Why is this popping up right now?
Wait, what are people putting into their thing? How 7x won't equal to
7x is equal to 48. Well, that means maybe we do need to turn it into a slope intercept form to find it. I mean, you can guesstimate here that this is going to be If you divide both sides by 7, this is going to be about 6 and 6/7, which is really, really close. Wait, no, sorry, 8, and I can't do math.
Wait, it's 40. I'm twitching. 40 divided by 7. This computer's laggy. 6.85715. I don't want to read all that.
Okay, yeah, 48 divided by. Oh, I should, yeah. So if it was 49, 49 divided by 7 is 7. So it's a little bit less than 7. So 6 and 6/7. Yeah, that would be better for next year. I'll make that change. For next year, let's do 42. Sorry, guys. Let's do 6 and 6/7, which is there. Let's pretend Khan Academy would allow us to graph 6 and 6/7, which it can't. And then we'd graph a line through those points. And that one is going to look really different. Oh, but it looks like there is an answer. I believe 6,1 works for both of those. Does that actually work? 6,1. So if I plug in 1 for x, that's 7. 6, or sorry, 1 for y, 6 for x. So 6 times 7 is 42. Oh yeah, that is a solution though. It's weird that I gave you such a weird problem. But yeah, the solution is 6,1. Why? Because it's the point that is on both lines. It is the intersection of those points. So if you want to think of just the intersection of points as the solution graphically, that's awesome. That's your low-level answer. But your high-level answer is it is a point that is on both lines. Because being a point on a line means you're a solution to that line. Being a point on both lines just means the intersection. All right. Hopefully I didn't make any mistakes on example number 4. Let's see if you guys can do it. So try example number 4. There it is. Good luck, guys. Who would like to graph our first line? We can do it in steps 2. Carlos, ¿quieres tratar? Oh, what's going on here? Y la escalera? Down to? Bajad? Right 3. Aquí? Es cerca, pero no es 2 bajo, es 2 atrás. Si es negativo, es bajo. Si, or baja. All right. But good, yeah. And then you can do the same thing in reverse. So you can go down to left 3, down to left 3. All right, thank you, Carlos. And we can make a line as well. Let's go. Let's make that a blue line. All right, what about the second equation? Who can graph that? I think everyone's in now. Ripley, you've been waiting patiently. Go for it.
So you cross out 2 and then you 1 y.
1. Yeah.
Y by itself is 1. Divided by 10. 1 divided by 10. Negative 10.
Yep. So y is negative 10. Come down here, graph negative 10.
And then x would be negative 5.
You get 2x is equal to negative 10, and therefore x is equal to negative 5. Up there, and then you connect.
And the intercept is negative 3 or negative 4 3.
Negative 4, 3. Oh, what'd you get, Jose? I don't know if we did it correct. There's no guarantee.
No, you did it correct.
Oh, what was your mistake?
I went like this way. So I went 1 up and then 5 to the left.
Oh, yeah, you got a positive 5 instead of a negative 5?
No, it was okay, so it was a negative, but I did it this way. I went from this point 1 up and then 5
Oh, okay. You thought that was the slope instead of the intercept.
Yeah.
Got it. Okay. Yeah, it's good to catch that error. Yeah, the more errors that you guys find, the more errors that you can avoid when you hit the quiz or the test, right? That's the whole point. Yeah, and then Ripley also labeled our point. This is the answer. This is the solution to both equations. It's the intersection. That solution is -3, -4. So we can say -3, -4 is the answer. The answer is -3, -4. Maybe we should be boxing that. I always say to box the answers, right? You can box the answer up here. 6, 1 was the answer up here. We can box that. All right. Fist of 5 on system of equations with graphing. Our objective was to test solutions to equations. That was part 1. And then part 2, solve with graphing. Well, yeah, because you weren't here. 5, 4, 4. Is that 3? If you guys hold up your number like this, it's really hard to tell exactly how many fingers you're holding up. So if you can go and turn it perpendicular. There you go. 4, 3, 4, 5. All right, thank you. And 5 for Georgia.